Good evening. Sorry, good evening. Can you all hear me? Guys, can you all hear me?
Yes, sir.
Yeah. So how many of you watched yesterday's video? Decision tree. I think the video is very, very slow and you can easily understand the problem. How many of you watched the video? Inductive bias, just introduction, and the decision tree and decision tree problems. Can you raise your hand? No one? Why? Then what is the purpose of giving a video? Simply I can cancel the class now. Why should I take it in somewhere in the morning? I need to give it. I don't want to leave you as a free. I want to engage somehow. The same can be taught again. Tomorrow also we have faculty recruitment up to 6:30, 9:30 to 6:30. So probably I may wind up before 5 o'clock probably. If possible, I will join, or else tomorrow all the classes were cancelled. Only for CSE, for few faculties, those who are into the panels, I think you may get instruction. Let's see. So then I should start from here. So okay, you can watch the later. So decision trees anyway, I am just in the name of a practice problem, just I am refreshing again the decision tree. I think you might have studied in data structure same, but here for the how we are applying decision tree for classification problems or regression problems. That is only the difference. Remaining the logic and everything is same, right? So now, so what do you mean by this decision trees? Anyway, problems I'll teach again. So what is a decision tree? So decision tree, any idea what is a decision tree? Decision tree is a supervised learning technique, right? So there are three techniques in the ML algorithm. One is a supervised and unsupervised and the reinforcement learning, right? So there are three learning algorithms: supervised, unsupervised, reinforcement. So decision tree is a one of the supervised learning technique, which is used for both classification and the regression problem. Okay. So maximum it will be used for your classification problems, right? So this decision tree follows the tree structured. So it will always follow the tree based structure. So where internal nodes represents your features of the data set. So here we are comparing the tree with the data set. In real time, what we will do, we will give a data set. From the data set, the columns are called as a features or attributes. The value from the columns will be taken as an input. So same way here, the internal nodes are represented as features because we need to map, right? So features and branches represent the decision rules and each leaf node decision represent the outcomes. That is how we are mapping our decision tree. All the internal nodes are feature. Again, your branches are decision rules and leaf nodes are outcome. The end the leaf nodes, the nodes which don't have children are called leaf nodes. Such nodes represents the outcomes, right? Now in this decision nodes, here we used to call a decision node and leaf node, only two nodes, the top node and the bottom node, right? So this is leaf node. So these leaf nodes is used to make any decision. This is used to make a decision. This is used to, sorry, your decision root node is used to make the decision. This leaf node used to take is considered as the outcomes or output of the decision. So that is what this decision tree is related to this. So generally the decision tree is a graphical representation for getting all the possible solutions to a problem or decisions based on the given condition. So here you may have number of solutions. So from the decision tree what we will do, which is the best solution? So which is the best classifier? That is what we are going to predict from this decision tree. So decision tree will give you the best classifier. So that is what the purpose of this decision tree is all about, right? So in order to build the tree, we use CART algorithm. CART stands for classification and regression algorithm. So that is what we used to call CART algorithm, classification, CART. So CART algorithm, right? So decision tree simply asks a question, and based on the answer yes or no, it further splits into the tree. Suppose if you say yes here, it will come in the left side. If you say no here, then it will come in the right side. That is what your decision tree. So then when you fetch the node, we will do the comparison with the decision node, then we will fetch the results. So this decision tree will work based on yes or no pattern, Boolean pattern, right? That is what this decision tree is all about. So and this is the simple representation. The decision nodes are nothing but your root nodes. Again, this is another decision node. Decision node for this level 0 node. This is the next decision node. Decision node. This is level 1. We used to call level 2. This is your level 3. So for this decision node, this is we used to represent as a subtree, right? So leaf node, leaf nodes, leaf node, then leaf nodes. So these brown colors all are we called as the outcomes, right? These are all we used to call as the features, right? So now there are different terminologies used in this decision tree. One is a root node, leaf node, right? So when you say root node, there only your decision tree starts. When you say leaf node, that is your final. There only your decision tree ends. Splitting meaning dividing the decision tree, right? So again, the subtree is, as you know, that there is a parent, the node which has a parents. The node which has no parents is called root. The node which has a parent is subtree. So pruning is generally a process in decision tree. We will use this pruning process in order to remove the unwanted branches, right? So unwanted branches may be the in previous case here there is a node. So this is which is unwanted. No, there is no more levels are there. So suppose I want to remove this leaf node, then I can say this is we can do through pruning method. The parent node or child node, the root node of the tree is called parent node, and the other node all are called a child node, right? So how does this decision tree algorithm works, right? So decision tree algorithm works by comparing the values of root attribute, right? So that is the how the this is how the algorithm works. So by comparison, here the mathematical operation what we do is comparing. So equal to or equal to comparison operator. So we are compare this algorithm works on comparing the values of root attribute with the record. When you say record is a real data set or attribute based on the comparison, follows the branch and it jumps to the next node. For the next node, the algorithm again compares the first attribute value with the other subnodes and move further. It continues the process until it reaches the leaf node. So you can see the steps begin with the tree with the root node, yes, which contains the complete data set. The second, find the best attribute in the data set using attribute selection measure technique. So attribute selection measure technique is it's a term which is used to identify the best classifier. So these are the one of the measure in one of the evaluation parameter. So under this we have two parameters. One is you can use information gain as a parameter in order to identify the best classifier, or else you can use the Gini index in order to identify the best classifier. So these are the two evaluation parameters. Like how will you evaluate your learning machine learning model, like a precision, accuracy, recall, likelihood, right? So similarly here the class decision tree is evaluated based on the either information gain or Gini index. Once you identify the best attribute, then divide the S. S is nothing but collection of trees. S is splitted into subsets that contains the possible values for the best attribute. Generate the decision tree node which contains the best attribute. Recursively make the new decision using subsets of the dataset created in step 3. Continue this process until the stage is reached and you cannot further classify the nodes. So then that node considered as the leaf node. So this is what the decision tree works. Decision tree or else sometimes we used to call ID3. ID3 is nothing but iterative disostometer something. Disostometer is nothing but dividing the tree into two halves. Then you can say D, the disostometer. So that you can check ID3. So the both are same, decision tree, ID3. Suppose there is a candidate who has a job offer and wants to decide whether he should accept the offer or not. That is the scenario. So a candidate has an offer, but he wants to decide decision, meaning he needs to take a decision. So whether he can accept the offer or reject the offer. So how can he take a decision based on the parameters? So based on the condition. So to solve this problem, decision tree is started with the root node salary attribute by ASM. ASM is nothing but the attribute evaluation parameter what we see in the previous slide. So salary attribute, the root node split further into next decision tree like distance from the office and one leaf node based on corresponding label. And the next decision node further gets into two decision, I will split into one decision node called cap facility and one leaf node. Finally, decision node split into two leaf node, accept the offer or deny the offer. So now the salary, then from here, then distance, then cap facility, then accept or reject. So this is how your tree has created, right? So now you can see salary is between suppose 50,000 to 80,000. So now if it is a yes, then you can say off whether you can check whether office is near to my home. Suppose if yes, then you can say whether the cab facility is available. If yes, then you can accept the offer. So if suppose no, decline the offer. If office is not nearer to home, then decline the offer. If salary is not between 50 to 80, then you decline the offer. So these are all your no cases. These are all your yes cases. So this is how this decision tree is created. So what is the purpose of finding this? So in order to find the best fit, best classifier for their learning algorithm for classification problem, that is what this your decision tree is used, right? Underfit, overfit, that we will know. We'll come to know next. Underfit and overfit. Overfitting meaning, so your model is learning the noise. So suppose if there are more errors, missing values, null values which are introduced in your data set, right? Suppose there are more noise has been introduced, noise in terms of error or missing something, so then learning will be disturbed, then your result will become very low. You might have seen, you might have worked with your machine learning labs and you worked on deep learning machine learning papers. You might have you are unable to receive more accuracy because of you might have not done the pre-processing properly, you have not removed the null values, you might have not removed the outliers, right? So missing values may be there, so because of that you are unable to get the results, so that is why you are getting low results. So if there are more noises are introduced, obviously it will lead to overfitting, right? You cannot reach the proper best fit, it will go to overfit. So something is going to dominate, then obviously it will lead to overfitting. In this case, you have a small training error, but very large validation error. So there are two types of error. One is a training error, another is a validation error. Training error will happen during a training time or learning time, and validation error will happen during the testing time. So both when you say training and testing data put together, we used to call as a data set. That you should know what is that, right? So if you inspect by plotting a graph, the evaluation of the training and the validation errors, you see that training error is always going down, but validation error is going up at some point. That is the point you need to stop training to avoid overfitting. Suppose whenever graph is happening like this, so some kind of validation error will go like this, then another one will go like this, go down, this is go up, so then you cannot meet the best fit here. So then by the time you should stop your training your model. So that is why you can avoid the overfitting. Underfitting means that you still have a capacity for improving your learning. For example, in a data set, you have only one row of features, you have only one features. Then for so that is your underfit, right? So means you have used the capacity more than the needed. If you use the capacity more than the needed, then overfit. If you use the capacity least than the required, then you can say it is underfit. So this can be explained with the data, that is your training set and the testing set. Both training set and testing set together we used to call data set. So when you say training data set is used to train the model, the testing data set is used to evaluate the model. So what will happen during training? Training meaning, so during learning. When you say training, we will load the data, then we will extract the feature, then we will train the model, then we will go for evaluation. When you say testing, we load the test data, meaning few samples from the possible test cases, then we will extract the features. Training meaning here we will predict using model, then evaluate here nothing but result. So this is before learning, test is nothing but after learning. So this is how your best fit and worst fit. So best fit will happen due to a small training set. Another one is your noise, another one is a missing values. Error rate decreases as the training set gets larger. So whenever the training set gets larger, error rate always decreases. But suppose if your training sets gets very less, then obviously error rate will go high. Here in such cases, pruning is a solution for overfitting. Remove the least reliable branches, then apply majority voting techniques, then pre-prune. Here there are two techniques. One is pre-pruning, another one is the post-pruning. So if you want to remove the unwanted branches. So this is how overfitting works. So when you say overfitting, you can see this is this is like your overfitting. Features are noisy and uncorrelated to the concept. Modeling process is very sensitive, but here you can see here in such cases, searching is very difficult. So you cannot take the best classifier either here or here. So everything will be your somewhere with high difference. Underfit meaning learning too little of the true concept. That is your underfit. So we are learning, we are considering only two set. Suppose assume this is your concept, right? Concept learning. So you have 500 plus hypothesis. You are taking only two hypotheses. One from positive, one from negative. Will they accept? I am taking only few sample, one positive hypothesis, two negative tests during testing. Then out of 500 hypotheses, if I test only one and one, then obviously it is underfitting. Features don't capture the concept, too much bias in the model, too little search to the fit. So this will lead to linear, right? You can see this diagram. Underfit, optimal and overfit. Underfit, you can see underfit meaning there will be a high bias will be there. There is a high bias underfit. Then overfit meaning there will be a high variance. There will be major variance. Underfit always has high training error and high test error. That is underfit because data is not utilized so far. Overfit meaning very low training error and high test error will be there. Right. So optimal meaning both will be low. This is how we can see this is underfitting and overfitting. So this side you can see this is your underfitting, this curve is underfitting. So here it is gradually, the test data is gradually decreases. So here also this is the overfitting, this is also error rate is, it is going down and is going up slowly, it is increasing. So obviously this is error ID. So error is increasing, so meaning so low bias and high variance. Here high bias and low variance. So what are the advantages of decision tree? It is very simple to understand and it follows the same process which human follow while making any decision. Also, it can be useful for solving decision related problem. It helps to think about all possible outcomes of the problem. Also, less requirement for the data cleaning. Disadvantage, so decision tree contains lot of layers which makes it complex. It may have overfitting issues which can be resolved using random forest. This overfitting issues can be resolved by the next algorithm called a random forest algorithm, which we will see in the next class. For more class labels, the computational complexity of the decision tree may increase. So this is what your decision tree advantage and disadvantage. If you notice yesterday's class, I have given this problem statement. So if you watched, you can solve this problem. So before that, I will take you to the yesterday's problem so that you can understand. I think many of you have not watched the video. So that is why I just prepared the basics. So now, so this is a given problem now. So assume A1 and A2. There are two scenarios, but different hypotheses, different positive and negative hypothesis. So which is the best classifier? Which is the best attribute? This is what we want to find out now. So are you all there with me?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So now this is how problem starts. And now so the first can you able to predict where this 29 plus and 35 plus came from the table? If you remember, if you recall the finders algorithm and candidate elimination algorithm, there will be a table. From there, the target concept is yes and no. So 29 plus meaning 29 yes type. 35 no type, positive hypothesis, negative hypothesis. Same here. But here the sub branches are 21 positive hypothesis, 5 negative. Here 8 plus 30. So 21 plus 5, 26. 8 plus 30, 38. So these both together how much? 30 plus 50. So 64 hypotheses were given, out of which whether this is better or this is better, that we want to calculate now. Same here, the second scenario is given, same 64 hypothesis, 18 plus 33, so 40, 52 hypothesis. So here it is 13, 53 plus 13, same 64. So this is what the hypothesis given. Now we need to identify the best attribute, best fit hypothesis for the decisions, right? So now you can see the collection is given, S is a collection. So this is nothing but now here we need to, this collection S contains both positive and negative examples of the same target. So that now we need to calculate the entropy S related to the Boolean classification. How do you calculate the entropy? Entropy is nothing but S is nothing but the sample collection. Sample of training example. P is nothing but a proportion of positive example and the proportion of negative example. So when you say proportion of positive example, so minus P by P plus N. So P is nothing but positive hypothesis example, N is nothing but negative example. So minus P by P plus N log 2 of P by P plus N minus negative test case N by P plus N log 2 N by P plus N. So simply is nothing but a positive minus negative training example. So that is we want to calculate now. That is the entropy of S collection, overall collection. Is not S is nothing but here A1 and A2. Now we can see here simple example is taken, entropy of 9 plus and 5 minus. So 9 is nothing but positive. So 9 by 9 plus 5 is 14 log 2. Then minus negative test case 5 by 14 log 2 divided by 5 by 14. So now my the value is 0.940. So similarly, if you calculate for anything, so you can get this answer. So you will get some values. So now this is your entropy calculation. Now after calculating the entropy, then we need to move on to the calculating the average information entropy. That is nothing but I. right? So column wise we need to calculate that is what this I attribute entropy. So that is a summation of, there may be different columns, maybe there sunny, rainy, cold, then your temperature, then there may be another cycle. So there are different columns will be there. So you need to calculate the I attribute for individual columns. Finally you need to add that column. That is what the summation of P plus N, Pi plus Ni meaning positive plus negative divided by P plus N into, this is star, so into entropy of A. Entropy of A is nothing but each individual feature, each individual feature. So this is each into, wherever, suppose you are calculating for this first root, then this is your entropy of A. Now we are calculating for the next child node. Now this is your entropy of A, right? So now finally you can calculate the information gain. As I told you, information gain is one of the parameter for evaluating your decision tree. So in information gain, you can calculate S comma A is nothing but entropy of S minus I attribute. Entropy which I already calculated minus I attribute also here calculated, so that we can directly subtract it and we can get the answer. Suppose whatever the values we are getting high, that is your best classifier. So now you can see this. First for the root we need to calculate the entropy. So entropy is something like 29 plus 35, attribute A and B. Possible values for A and B is this one. So entropy 29 plus 35. So now we need to calculate the entropy of 29 plus 35. The formula we know, minus P by P plus N log 2 P by P plus N minus N by P plus N log 2 of N by P plus N. So then when you calculate, so P is nothing but 29 divided by P plus N is nothing but 29 plus 35 is 64. Here 35 by 64. So when you calculate, you will be getting 0.99. That is your entropy of this root. Right? What is this root? 29 plus 35 is 0.99. So now this you need to calculate the entropy of this, entropy of this, entropy of this, entropy of this. So now entropy of 21 plus and 5 minus, what is that? 8 plus 30 minus, what is this? Can you calculate and tell me? What is the entropy of 29 plus 35? So when you calculate, this will become your 21 plus 5 is a 26. Here 30 plus 8, 38. So you can see here. So now 29 plus 35, this is 0.9, we already calculated. Now I need to calculate for this entropy. 21 plus 5 minus is nothing but the entropy value what I am getting is 0.71. You calculate it in the similar pattern, right? This pattern. You can use this formula, minus P by P plus N log 2 of P by P plus N. So now the second one, I need to calculate the I attribute. How can I calculate the I attribute? I attribute calculation is given summation of P plus N divided by P plus N into entropy of A. Entropy of A is nothing but this attribute, current attribute. So now we can see entropy of S is nothing but this gain or root is nothing but A entropy already calculated 0.99 minus this I attribute is nothing but this I attribute is nothing but summation of p plus n divided by p plus n into entropy of A. So now that is 26 divided by 64 into here p plus n divided by p plus n. So 26 entropy of 21 plus 5. So 26. 26 divided by 64 into entropy plus 38 the other side 38 divided by 64 into entropy of 8 plus 30 minus. Now when you multiply this 26 divided by 64 is nothing but 0.406 into entropy of 21 nothing but this 71. So this you can keep here, this you can keep here, multiply you will get 0.722, subtract from 0.998, 0.27 is your gain here. Similar way here you calculate for entropy here, again here, then here. Then entropy of S minus I attribute. So what is I attribute? I attribute is nothing but this one, right? So 18 plus 33, 51 divided by 64, same here. Then 13 by 64. When you add all together, 13 divided by 64. When you add 18 plus 33, 51. So when you add all hypotheses together, that is 64. So now subtracted entropy of 18 plus 34 is nothing but already calculated 9.4. Here 11 plus 2 is already calculated 6.2. So you can add it and send. So now A has 0.27 but B has 0.12. So A provides greater information gain. A provides greater information gain than the B. So what we will do? So we will say A is the best classifier than B. That is what your decision is all about. Okay. A is the best classifier than B. Right. So now same, I think I have given another example here. The same way you can check it out. So here I have done. So now the here table is given. So now you take how many positive test cases, negative test cases are there based on yes or no. Yes is 1, 2, 3 up to 9. X is there. So 9. So again no is 5. So 9 plus 5 is 14. So now you can have 14 hypotheses are given. Based on that you can do the same calculation here. So here first you try for outlook, then you try for temperature, then you try for humidity, then try for wind. So totally 4 classifications we need to do. Okay. So this is I already solved. I think I have explained clearly in the PPT. You just have a look at it. See how we are calculated individual. First we calculate for outlook. Outlook has 3 parameters. One is sunny, overcast, and rain. In sunny, how many positive, negative? 5. Then what is the entropy of 5? Then this one. 4. Whenever you have a 0, when you multiply with 0, then obviously you will get anything. So nothing. So 0. So here you can take. So gain of S comma outlook you can calculate. You know how to calculate 5 plus this 5. So you try to get the gain, so you will get 0.247. Same for outlook component, you try 0.247. Same humidity component, you can try 0.151. So here it is 0.048. Temperature 0.07. So out of which you can say which is the best attributes. Outlook has the high value, outlook has the high gain. So you can take output as the best classifier here, right? Highest gain attribute. So outlook is your best attribute. So this is how your first question. The second question. This is I given as a second question. So how many of you worked out? I don't know. So let's see. So now can you take this as a problem and can you do it? Solutions, I will, the problem, do you need a formula for this? Can you try this problem? Just I'll give you a formula slide so that you can guess. So this is your formula. You can just take a screenshot. This is your question. So this is your question. You just note down. So there are four columns. One is a color, then type, then door, then fourth one is tire. Then classes given. Plus means positive hypothesis. When minus means negative test cases. So you just identify what type of cars are given. So you should play with the cars here now. Okay. It will come like this. You take a car and guess just what is your best idea. So, let's see. This is your question now. You can see here. Selecting the first root attribute. See, now you have a table. This is what the given problem. Okay. So now you need to construct a decision tree. Got it? So how do you construct? If you want to construct a decision tree, then you should know what is the root node. How will you find the root node? Then you need to solve the problem. So what is the first attribute? Color, type, door and tire. So first we'll start deriving the entropy function for the color. You can see here the color attribute is given. So this is your color first attribute. Now color has a three features. One is a red, blue, green. Under red you have red cars. See the different cars are there. So totally 4 cars. Here 4 cars. Here you have 6 cars. So then how do you find the entropy value? The 5 plus, there is a 5 total number of positives are, see the plus is given, plus 1, red le 2 plus, blue le again 1 plus 1 plus 2 plus 3, 4, 5. Totally 5 positive hypothesis, 9 negative hypothesis. So if you calculate the entropy, 5 by 5 by how many 14, 5 by 14 log of 5 by 14 minus negative is 9 by 14 log of 9 by 14. So you will get the answer 0.940. That is your first entropy value for this color. Now you can go ahead with the information gain, the S color sample of color of. So entropy value of the root, the entropy value of this root is nothing but 0.940 minus I attribute. The formula is entropy minus I attribute. So I attribute is nothing but we know, right? So how many what do you call positives are divided by I mean P plus N, right? So P plus N divided by P plus N into entropy value. So P plus N is nothing but how many P plus N here? For there will be 3 cases, red, blue, green. So totally P plus N is nothing but 4. So 4 by overall P plus N negative, including negative there will be a 14 into the entropy value of this color, entropy value of this red. How much we have calculated? Into entropy of A. Entropy of A is nothing but 1.0. Here you should calculate this red car's entropy value E of 2 positive plus 2 negative. What is the value? Here they given 0.1. So this is for this again 2, 1 positive, 1 negative. So their entropy value is into 0.81. So here 2 positive, 3 negative. So that value is 0.918. So here totally 4, here 4, here 4. So 4 by 14, 4 by 14, 6 by 14 into the entropy value. The individual features entropy value 1.0, 0.811, 0.918. So when you subtract, you will get 0.029 is your gain for the color. Same for type. From the table you can see second column is the type. So now type you have a 3 category: mini car, minivan and SUV cars. In cars category you have these many cars, totally 5 cars. That is what this 5 stands for. So this 3 stands for number of cars. So 6 stands for number of cars. Divided by overall P plus N. Overall is, so 5 plus 3, 8, 8 plus 6, 14. So totally 14. That is what divided by 14. This 0.71 is nothing but E of how many positive? 3 positive plus 2 negative. That is nothing but 0.791. So here is only 3 positive, so only 0 positive, 3 negative. So this will become obviously 0. When you take log 0, 0. So this parameter will go 0. So then 6 by 4 into here 2 positive, 4 negative. So the value is, entropy value is 0.918. So when you do this calculation, this is 200. The first selection route is your 0.29. This is 200. Similarly, for a door, you will get 0.152. But tire, you have 0.048. So out of these 4 values, you compare these 4 values here. What is the first value here? 0.029. The second value is 0.200. Third value is 0.159. Fourth value is 0.048. So the 2.200 is the highest value. So then this is your nothing but your best classifier, best attribute. Type of gain is nothing but 0, now then this type is your root. Now this is the highest gain. So this will become your root node. That is what this node. See here, the root node is your type. Now this type has 3 cars. Now you need to find the next parent node, door. So except type we have 3 more. So again you need to start calculating for colors, doors and tires, other columns. So then you classify this. So when you take a type from the table, always refer the table. When the type column you have 3 cars, car, minivan, SUV. In car category, these are the cars. 5 car categories are there. 3 minivan category. 6 SUV category. Now you start calculating the same process. 3 plus 2 minus. Entropy is 0.971. So here it is 0. So positive cases are 0. So 0. So this one. Again, if you start calculating for type, car, doors. So you can see doors has 0.71, tires has 0.918. So this has less value. So this will come in the left side. This has highest value. This will go in the right side. Again, now take a door. Door has a 2 positive, 4 negative. Again, start doing this. So until you reach leaf node, you will get like this. Okay. So this is how your this step is calculating next attribute. This is your step 2, level 2 calculation, right? Level 2. So selecting next attribute. So this is how you need to do the decision tree. So the same algorithm can be solved using machine learning in Python, right? So with our 50 lines or 40 lines of code. So this is the process, how the decision tree is happening, how the decision tree is generated. This is what happening. So this can be implemented with the Python in lab. So anyway, once your lab is started, you can start all these experiments in the lab. The concept wise you can understand here, but the learning, the practical part, you can try it in lab part. So this is how the decision tree is all about. So this is, you can try it in Python implementation of decision tree, which is available in the T points. So you can check it out later. So that is your decision tree. Okay. So now you can try, there are 3 to 4 questions are given in this PPT, both the PPT. You try to solve this. You try to solve again same problem first, then later on you can go with any other new problem. You take any table and you can start identifying positive and negative, right? So that is your decision tree is all about. Next class will start with ensemble learning followed by your random forest. With that your first unit gets over. Okay, we'll see. So let me download the attendance. Please give me a moment. Slot. Tomorrow's class, either I am coming or not. So anyway, if I am unable to come, if interview is not over, anyway I'll join or I'll post a message in our teams. Please you try to follow the message.